you should be able to. Okay.
Okay, and then I will, Stephanie, I'll pass to you host momentarily.
All right.
Welcome back, everyone, to day 2, Wednesday, April 24th. Day 2 of the Cybersecurity with Python and the Microbit Workshop. And as I mentioned previously, there's lots of useful links in these slides, so I'll go ahead and chat you with that. And then I need to also look at the participants. Find Stephanie. Oh, we have somebody in the waiting room. Admit. There you are. Make host. Yes. Okay. How's that look, Stephanie?
Good.
Okay. All right, continuing on. A reminder that you can click the view. If you move your mouse around, a little view button will appear in the upper right. When you click that, you can exit full screen, and then you can arrange your screens so that you can comfortably see both the presentation and something that you're working on. If you have 2 monitors, that probably doesn't matter as much, but if you have a single monitor, that's important. And then remember to close as many other apps and as many other Chrome tabs as possible so that your Zoom and Microbit Python editors can coexist on your system, because both of those are kind of high bandwidth consuming devices. Today we're going to be talking mainly about some of the microbit cybersecurity examples. We mostly talked about scripting and Python scripting and the microbit on Monday. We still need to talk about strings, so we'll be doing that. And then we'll move on to radio basics and data, and then we'll do encryptions, sniffing, and brute force attacks and defenses on a microbit radio network. So let's see. I think that I want to make sure that everybody has a chance to get their set up so that they have one microbit that is connected to or pardon me, one microbit Python editor that is connected to a microbit and testing it to display A, and then a second microbit Python editor tab with B displaying, and then that way you can prove that you have 2 different microbit Python editor tabs, and they're able to load scripts to 2 different microbits. So let's go ahead and have everybody plug it in. I will potentially throw a big old monkey wrench into my presentation by just basically demonstrating that if you unplug both of the microbits and then plug them back in, keeping one's fingers crossed that as a presenter it doesn't completely send my system into chaos. Now I should be ready to go and hit connect and choose a microbit. And I see that the upper one for me ends in the number 3000. So I will connect that one and assume that it's microbit A. And then we'll go to the other tab and click connect. And then choose, for me, the number ending in 5000. And then we'll hope that that is microbit B. And so now, now I'll go ahead and send to microbit and hope, see the A disappeared here, and then now it reappeared, and then click the other tab and send to microbit. Now the B disappeared, and then after the script loaded, it reappeared. And so I want to make sure that all of you have two tabs, and each one is able to send a script to a different microbit. So that's okay, one thumbs up. Excellent. And go ahead and either chat or click the reactions and choose a thumbs up when you've got that up and running. 2 thumbs up, 3, 4, 5. Excellent work. 6, 7. And I just realized that I might not be seeing everybody who's 8. No, I think I have everybody shown
We have
on
the
one screen.
request to paste the code we need to run.
Okay, so what that is so I'll paste both of them then. So here is for microbit A, copy, paste. And then here is for microbit B. Very similar code. Paste. And so yeah, those are what you want to have in your separate python.microbit.org/v/3. Homework done. Well done. Let's see, I have one connected. Can you give directions for connecting the second one? I missed that. Well, basically, I'll go ahead and unplug mine again. Okay, so I'm unplugging both of mine. And I'll count to 3 and then plug them back in. And at this point, that action is going to cause both microbit Python editor tabs to be disconnected from any microbits. When I unplugged and plugged back in, now the microbits are just sitting out there unconnected to any computer software. And so what you have to do is in each microbit Python editor tab, you have to hit the 3 dots and select connect. So I'm in the first tab right now and I'm selecting connect. And then you can actually hit don't show again if you want to skip the all this. And what that'll do is then we end up in the microbit, python.microbit.org wants to connect. And because I have 2 microbits connected to my system, it's showing the 2 serial numbers, one for each microbit. And this is kind of like it's the physical address of the microbit. And incidentally, somebody suggested on Monday or asked if there was any similarity between the little tiny FCC ID that's just above the antenna. And I realized later that FCC ID is basically for FCC permission to operate this microbit radio. And so it's going to be the same on each microbit. All right, so anyway, so here we are still in the first microbit tab. So you have to select one of the 2 microbits and also make a note of like the ending digits. For me, conveniently, it's ending in 3000 here. Okay, so that's the first microbit. Now I'm moving over to the second tab, clicking the 3 dots next to send a microbit again, selecting connect, and then you can hit don't show this again, or you can just go through the next. And then you have to make sure on your second tab that you select the serial number that you did not choose in the first tab. So for me, that's the one ending in 5000. And so that's still an available microbit. It's not connected to another tab. So I hit connect, and now each tab is connected to an individual microbit, so that when I hit send to microbit with the first tab, one microbit shows A. And then when I hit send to microbit with the second tab, the second microbit shows B. Okay, excellent. So hopefully we're all good. Excellent. All right, give me a shout out if you need any help with that. Otherwise, we'll go ahead and move on. Now, the next thing I want to show you is that when you have two tabs next to each other like this, you can pull them apart. So you can grab one of the tabs with your index finger on the mouse and drag it away and let go. And then you'll have essentially two separate windows. And once we have two separate windows, what we can do is test out the chat application. So I'm going to, I'll demo that first, just to, I know many of you have done that for your homework, but it's also good for any of the independent learners who come after us to get a chance to try that. So we'll go to this slide and select bidirectional texts. And okay, so now I'm on the bidirectional texts page, which I will post the link in a minute. But first I'll demo what we want to do. So here we have the concept diagram where it's showing, okay, we have a terminal, it's connected by USB to a microbit transceiver. It's having radio talks with another microbit transceiver meaning bidirectional radio. And then that also is having a conversation over USB with the computer on another terminal. And so that's what we'll be doing here with this script. And so when you copy the script and paste it in, and again, this whole copy and paste approach, it's well and good for a 6-hour it's well and good for a 6-hour short course, but if you're trying to learn the language, it would be better to type as much of this as you can. Now, the instructions on that page also say to take one of those and change it from transceiver A to transceiver B. And then what you can do is send both of these to microbit. I will paste you the link to the script in a minute. You can send both of them to the microbit and then show serial in both of them. And notice that it says, hey, here we have transceiver A, here we have transceiver B. And so, so I can check to see if anybody else is on my frequency by saying hello. And notice that hello appeared in the other terminal. Now, again, I want to emphasize that what happened is I typed hello here. It went through the USB to this microbit. This microbit broadcasted that over its radio. The other microbit received it and sent it to its terminal. So, so I want to just remember that that's a radio conversation occurring. It's not just mirroring from one to the other. All right. Hi.
I just want to remind everyone, getting two to work on one computer isn't going to be necessary for the students because they'll be communicating with each other. So all of the extra hoops and difficulty that it is to do it two on your own won't be an issue in the classroom. Lest this
Yes,
seems
thank you.
discouraging.
Thank you, Stephanie. Indeed. Okay, so all right, so now that and remember, for this you want to have two separate windows. Now, however you decide to arrange them, I found that if you put these in tabs and try to do this, like if we open the, yeah, so we've got both serial open. If you have them in two tabs in the same browser, I can say hi here, and then I'll see that the hi came through. And when I say hi back and send it, I'll go back over here, but all I see is hi back. I see the most recently thing, the thing most recently received. Whereas if you have two separate windows and you're doing that, then you get the entire log of, oops. Well, you get the idea of what was typed. All right, and with that, I'll go ahead and paste you this link, and we'll have you grab this script in one of the editors, change transceiver A to transceiver B, run them both and see if you can repeat that chat conversation. And then go ahead and give me a thumbs up whenever you get that running. Yeah, nice. 2 thumbs up already. You guys are fast. Okay, I see a total of 4, 5, 6. Oh, 7. I should mention that in the classroom, some pandemonium might occur when the students are all chatting on a single channel. There is a radio config statement, and students can choose different channels to go into small groups. And from the cybersecurity standpoint, it's you might want to warn them ahead of time that they might be monitored and their conversation might be displayed on the projector, because what you can do with your microbit at the head of the class is go to various channels and see what kind of conversation is happening on each channel. The channels go from 0 to 83, and I'll talk more about that briefly in a little while.
That is a really good idea and a good lesson for cybersecurity, lest they forget that their conversations are not private.
Yes, and you can even emphasize that that's the case in many contexts in their online activities. Let's see, I think you mentioned this last time, but does this work on earlier? Oh, yes, it does work on earlier generations of the microbit. Yeah, it does not matter whether you have microbit A or B. I do believe, I'm trying to remember, there might be an extra long script on Friday that does not work on a microbit version 1. If some of you have version 1s, go ahead and let me know on Friday. And I'll see if I can try to remember which one. We should have we usually put notes in the tutorial if something's not compatible with version 1. And normally that just has to do with the size of the script. FYI, this works on Ubuntu Linux. Very nice. Let's see. Right now, I'm using a v2.0 and a v1.5. Cliff, do you have that 100% working? Were you able to connect to both microbits and get everything talking? 2204. Okay, yeah. So a recent Ubuntu. That's great. And then are you using the Chromium, Kevin, are you using the Chromium browser for that on your Ubuntu? Okay, let's see. What
No, this
defines
is
the,
Google
oh, Kevin.
Chrome.
Yes, yes.
Yeah, Google Chrome, but it very explicitly does not work in Firefox. Web USB has been blocked by Firefox.
Yes, it has. The two browsers for most computers that let's see. The native Mac browser also does not support it. The two that do are Chrome and Microsoft Edge, which of course, I'm sure there's no Ubuntu version of that. Or I'm assuming at any rate. All right, well, great. Let's see, what defines the length of the message that can be sent and received? That's a very good question. There is I'm kind of jumping ahead by going into this. Let's see if the API will show us. There is a default length, and I think it's like 32. And you can basically say length equals 32, and that would be probably the default. There is a slide where I'll be able to remind myself of that. And maybe this API on the left-hand side, if we go to microbit radio, there we are. Okay, let's see if the built-in documentation looks a little like it's lacking. Okay, I can find this. Okay, so here we are, and here's the introducing the microbit radio slide. And or pardon me, this is actually the introduction page in the radio basics chapter. And so we talk about that there's a little squiggly line. It's probably it's going straight across the top on the microbit version 1. It's going to go diagonally on the microbit version 2. And let's see here. No, that doesn't have it. So here we have the number of channels or frequencies. Yeah, I apologize. I'll have to go spelunking for the length argument. I believe that if I make these both length equals 250, and I think 254 is the max. All right, let's try that and see if it. Okay, now if I type the entire, let's see, this is a long test message that will have more characters than the default buffer would store. Yeah, so if I do that again without the length, without that length argument, and that is in the tutorials. We do talk about length. I just don't remember where off the top of my head. So now if I do that, see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7. So close to 30. All right. Oh, and what did I say the max length would be? From memory, I want to say it's 254. Maybe it'll burp at me if I say something wrong. 256. No red dots. Okay. Well, it's definitely not 256. I know it's south of 256. 254 is what I want to say. And we'll probably run across that before the workshop's up. Okay, what's next? So this chat application is one thing that we'll be repeating because it's one thing that really needs some encryption for, and then one thing that whatever encryption is used can be attacked. So this is one of several applications that we'll be doing. And another one is going to be, oh, you know what? Before I move on to that next one, Yeah, it's all good. Stephanie, could you send Phyllis any information she might need? Phyllis, the main thing I would say is to make sure that your identify microbit A and B um, is good, that you have two separate tabs that are connected to two separate microbits. And then if you keep them separate, then things like the chat application that we've been doing will be work a little bit better. Okay. Oh, channel equals 254. Yeah, that's no good. You want your channel for the sending and receiving microbit to match. And then length is the one that you can make much larger. Okay, so moving on. I'd like to jump back to string features briefly, because they play into just about everything beyond what we just did. And as a matter of fact, if you think about it, when I type something in here and hit enter, and it does its little travel up the USB cable, out one microbit, into the other microbit, and back up the USB cable to this terminal. What's happening here is that there is a string, this ifuart.any, just briefly, is basically checking to see if you typed any characters into the terminal. And then tx is a variable. And what we're doing here is this, basically, if any keys were typed, it goes into this input statement, and then those characters are stored in a variable named tx, and then the radio sends out tx, and that's a string of characters. And then likewise, this is also a string of characters, and I'm getting ahead of myself. I just wanted to mention that that I'm a little bit out of order here, because we haven't talked about strings yet, so I'd better get back to strings. There are quite a few native string manipulation features in Python. And the reason for that is because the online world has become very dependent on strings. I mean, if you think about, www.parallax.com or www.google.com, those are all strings of characters when you type them into an address field, and they get sent to the server, and the server along with lots of information about how to get back to your computer, and then the server sends you the web page information. And so strings are kind of ubiquitous. And so so the first thing I'd like to show you is that in Python, here's an example of a string. This one is contained between quotation marks, and I'll mention some of the other containers later. So all these characters in between the quotation marks make up the string. And more importantly, this string has each character in the string has a location. So H is the 0th character in the string. And since we named this string object here, S, the H can be accessed by saying S of 0. So we could say print S of 0 or display.show S of 0, and it would give us an H. Now, if we use H of 1, 2, 3, 4, 5, 6, or 7, well, 7 is going to be the character N. Strings also have some features. You can, for example, say, hey, a new S string can be set equal to the old S string from 0 to 7, and you don't have to put in a 0 if that's where you're starting. Plus the string great, and then plus the other part of the string here, and plus exclamation point. And then basically what's going to happen is that now your S string is equal to this. And under the hood, it went and destroyed the old string and then created the new string. And as soon as it did so, the old string is gone. Now the new string is what we made it to be. And so the new S equals the old S 0 to 7 plus great plus the old S. What is that? 11 to 15. It's behind my camera. Plus exclamation point, so that now we have our new S, and the old S got thrown in the trash can. Okay, close tabs to the right. And next up, so what I was saying about the string indexing is shown here. So students got to try a bunch of examples making strings. I suppose I should mention at least that they're introduced to a whole bunch of different aspects of strings. For example, strings can be contained by apostrophes or quotation marks, and that a single apostrophe works fine for one line, a single quote works great for one line, but another advantage of a single quote, or of double quotes, pardon me, is that you can, if you have double quotes containing your string, you can put single quotes inside the string. Some of you might remember that I got myself into trouble on Monday because I had single quotes out here, and then I had the word it's, IT apostrophe S, in the middle of everything, and that's why the program was showing an error for me. You can also do multi-line strings by simply using 3 apostrophes or 3 quotation marks. You can use a backslash in the script to connect them together. You can use things like \T and \apostrophe to insert, like here's a new line, here's a tab, here's an apostrophe that actually does fit inside a pair of apostrophes because it's a \apostrophe. And let's see what else. So this is an example of the many things that students get to see about the string features in Python. And it also talks about what I mentioned, which is that strings are used for exchanging data. It's also important to note that a string can be 1, 2, 3, 4 in between quotes, and a number can be 1, 2, 3, 4, but you can't really use those two together. You either have to convert one to a number or the other to a string before you can operate, before you can combine or do arithmetic with them, depending on which way you're going. It also talks about how data is encrypted. So here is a first example of encrypted data. And we challenge the students to try to figure out what that encrypted data is really saying. And so I might as well put you guys all on the spot and see if anybody can figure out what that particular string is an encrypted message of. I'll give you a hint. The answer is right in front of you.
Would it be
It's hello.
Ha! You guys did it. Good job.
Okay.
Very nice. Yes, because HIEF, LM. So what all we did was shift all the characters by one. Nicely done. And so that also is going to foreshadow more stuff later. So the one thing we do with students is have them try some of those different techniques that I just talked about with strings. I'll go ahead and paste this one into you. You can try it out on one of your connected microbits. And basically, S1, S2, S3, and S4 are all different strings with certain string features used, and then basically we're printing all of them, and so we can see see that each one printed, and it even shows that there's a tab right here and that the apostrophe came through even though it was contained by single quotes, because it was because a backslash, which is called an escape character, was used. Next up. Characters inside strings. This was another interesting one. Let's see here. So what we're doing here is talking about some of the features, and I feel like I've gotten out of order here. Okay, yeah. So students also on this page learn that there are functions that can do operations on strings. For example, each printable character and unprintable character for that matter has an what's called a ASCII or ASCII value. That's American Standard Code for Information. I was going to say exchange, but I'm blanking on the last.
Interchange.
Interchange, thank you. And so we have actually a whole ASCII page. I don't see the link here, but somewhere students will have come across the link. Here is the ASCII table and information interchange. Thank you. And so, as an example, capital A is the number 65, capital B is the number 66, lowercase a is the number 97, number 98 is lowercase b, and so on and so forth. And then there are some non-printing characters down below here. And then we get started with the space as ASCII 32. And so with that, we'll go ahead and try out those. Sorry, then you can also ask what the length of a string is. And you can convert other objects to strings. Like if you have the number 1, 2, 3 as a number, you can convert it to a string. Or in this case, what we have is a string that contains 1, 2, 3, and then it's using int of s, the name of the string, to take the characters 1, 2, 3 and spit out the integer equivalent of that, which is going to be then stored in the variable n. And at that point, you can add 1 to n and it will work properly. Whereas if you tried to add the number 1 to the string 1, 2, 3, that wouldn't go very well. Okay. And let's see what else to talk about here. Accessing characters. So here is one that prints a particular character, the 5th character. Have you try that out just as an example. Paste. And what this does is it shows that the 5th character is a capital F. And then looking at the script, the string is contains A, B, C, D, E, F. So that's 0, 1, 2, 3, 4, 5. So F is indeed the 5th character. Checking the length. Sure, let's do check the length. So this is a handy routine or a handy function that basically tells you the length, the number of characters in a given string. So it's saying that the length is 12. So if I go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, that's right. So even though the characters are indexed starting from 0, there is a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters in the string. And so that shows students, hey, you can ask what the length of an arbitrary string is before you do some operations on it. And the main thing I want to do here is just kind of emphasize that there's a lot of different tools that can be used on strings. And so I think compare, check, and find is probably a good one. And then converting data types I want to do, and then we'll finish it off with. Okay, so here is one where it's comparing. And the application is a password, which again is kind of a cybersecurity oriented example. I saved it. I meant to just send it to the microbit. All right. So the password is shrubbery, a nod to Monty Python and the Holy Grail, which you will find many of those in these tutorials because of the Python programming language developed for the microbit, a Great Britain product. So I'll enter an incorrect password. And it tells me it's incorrect, but if I enter shrubbery, there we go. And so the script would not let the students past this loop until they entered the correct password. Converting between data types is really important. So let's take a quick peek at that. As you can probably see, I'm really skipping through a lot of the chapter. This is definitely a chapter that has lots of things that students can do. With strings, there's a lot to learn there in order to become proficient for some of the scripts coming up. Let's see here, checking variable type. Yeah, that's a good one, but I'll just show it to you. Okay, so so the convert intro script is just basically showing the difference between adding a string to itself and adding a number to itself. I'll go ahead and paste that into you. And then we'll paste it here and run it. And so if we have a string that's 1, 2, 3, 4 inside quotes, if we add 2 instances of that string into quotes, we get 2 1, 2, 3, 4s connected together because it's 1, 2, 3, 4 string plus 1, 2, 3, 4 string. And then that becomes S2, which is what is displayed right here. Now, if we have a number that's 1, 2, 3, 4, then we can add those 2 numbers together and we get 2, 4, 6, 8. And so that is a script that students run to basically highlight the difference between adding strings together and adding numbers together. Now, you can also convert. You can check the type, and then you can convert a string using int. Let's see here. Okay, so checking the type, basically, if you run this program, what it's going to do is tell you that since S is 1, 2, 3, 4 in quotes, it's of class string. And then since N is 1, 2, 3, 4 is an integer, it's saying it's of class int. We'll skip that one just to save some time. And then here is converting back and forth between strings and numbers, which is very important, because especially in the robotics and automation field, because that string will get sent across the network, but then it has to become a number for the computing device that's connected to the mechatronic stuff to deal with. So I'll copy this one to you and we'll run it together. Paste. I apologize. I'm not sure why Zoom likes to pull my screen back to screen 1 when I'm on screen 2. I'm not actually, in many cases, consciously doing. So here I'm intentionally going to screen 1, but oftentimes Zoom just kind of pulls me back there. And I think it has to do probably with, no, I don't even know. Some kind of notification setting in Zoom that I need to find. Okay, so here is our conversion script, where the string is 1, 2, 3, 4. There it is, in quotes. And then N equals int of S, takes that 1, 2, 3, 4, and converts it to an integer and stores it to the variable n. Then n2 is twice n.
And really nice jeans.
What's that, Stephanie? Stephanie? I
Nope, we're
cannot-
good.
Oh, okay. Alrighty. So here we're adding two integers together. And then here we're converting the sum of those two, the result of adding those two integers to a new string, and then displaying the string. And so the main thing to remember is that if you need a number from a string, use int of the string. And if you need a string from a number, use str of the number. And go ahead and hit me with any questions if you have any about that. One interesting thing I wanted to talk about, we haven't really done anything with it in the tutorials yet, but I do have plans to add something, is that essentially you can send strings between microbits and then execute the code. You can send strings that contain valid Python statements, I should say, and then those statements can be executed. And so I'll go ahead and show you how that works. I'll paste this, or I think I'd better demo this one first and then show you how it, and then paste it into the chat. So here is an example of a script that allows you to type in text, and then once you've typed in your entire script, you can say run, and it will actually do what was contained in the string as though it's Python statements. And so I could say for n in range 1, 4. Let's see, I'll just say print hello. I'm kind of freestyling here, so I might have gotten myself in trouble. We'll see. But there's a program, and then run should run it. Ah, there we go. So it did work correctly. And so if you think about this, you can easily send this text. You can, since it's stored in a string, you can easily exchange that between 2 microbits, and unfortunately also potentially embed code. And I just remembered that that in our cybersecurity tutorials, or pardon me, in our AI tutorials, we do have a cybersecurity segment about that. Okay. AI. So what this shows is that that ChatGPT was basically tricked into writing a script that introduced that allows you to enter a script into 1 microbit and send it to another microbit as a string. And then this is the script that ChatGPT gave me to execute the string that it receives. And we went around in circles, me and ChatGPT, that is, quite a few times to get something that works quite this well. And so after testing the scripts, I pointed out to ChatGPT that this could be used maliciously and asked it basically how to, how to prevent malicious use of that code. So yes, we are already using that particular feature of Python in a cybersecurity example. It just happens to be tucked away currently over in AI, where I had ChatGPT help me write the potentially malicious script, and then had it advise me on how to prevent the script from being used maliciously. And with that, we are at 4 o'clock, so we'll go ahead and take a 5-minute break. Let's see, since it's already looks like it's 4, let's do 6 minutes past the hour. We'll go ahead and take a break till then. And I need to pause the recording. Stephanie, it looks like Stephanie, are you able to see cloud recording?
Yes, I see that we're still recording to the cloud. Would you like me to put that on hold now?
Are you able to pause it? Because I don't have the ability to pause it on my end. Okay, welcome back from the break, everyone. Let's see here. Before I go any further, I should probably paste in the link to that AI with the microbit stuff, since it has lots of cybersecurity relevant information in it. Learn.parallax.com. And then artificial intelligence. And to summarize this, and I might actually talk about it a little bit more on Friday, the idea here is to show that, yes, AI can write scripts for your microbit, but it doesn't always do it very well. And the moral of the story being that it's still important for humans to understand how to write scripts, and they can't just leave it all up to AI to do for them. And then also that AI can unfortunately be used to exploit various vulnerabilities and make cyber attacks even more sophisticated, but it can also be used in detection and prevention of cyber attacks succeeding. And here is the link to that. Paste. All right, on to radio data. So this next script that we're going to run will essentially take data and put it in a dictionary. We talked about dictionaries on Monday, where dictionaries are something that are things that have key value pairs in them. And so what we're going to do is have a dictionary that has a start key, and it's going to have a value, and then it's going to have an after key, and that'll have a message. And the way this is going to work is that on Monday, we also did a script where we entered where to start counting down from, and then what to say after the countdown was done. Now, we did that just strictly connected to, with one microbit connected to one terminal. Here, we're going to do a distributed version of it where the countdown is transmitted by one microbit to one or more microbits in the network, and then the receiver microbit or microbits will perform the countdown. And so an example of where this might be useful is basically anywhere where you can't just shout to your fellow student to turn the switch. For example, rocket launchers and that kind of stuff would be examples of where this is useful. So here is the countdown script that you'll be typing into. So you might want to put that into microbit A's, or well, I guess I'm using microbit B for that here. So we'll put that in one microbit, and then the receiver script will do the actual counting down and displaying the message. And did I paste that to you? Yes, I did. Okay, so there's the receiver script. We'll put that in another microbit, send them both, or flash both scripts into each microbit. And then notice that on the left, it says that it's the countdown app and it's the microbit sender. And it's asking us to enter the countdown starting number. And I'll keep it a short countdown with the number 3. And then the message after the countdown, I'll just say lift off again. And when I hit enter, that's going to get put in a dictionary, converted to a string, and sent out the radio. This microbit will receive it and count down. So when I hit enter, there it is. Okay, and so again, that went to one microbit over USB. That microbit sent it out over the radio. This the microbit connected to this terminal received it and sent it back up USB and displayed it here. And what was sent was a dictionary, but that dictionary was put into a string before it went out over the radio. It came in here as a string and was converted back to a dictionary. And then the dictionary was parsed to find that the start value was 3 and the end message was lift off. And then it executed its part of the countdown script. And now we have 2 things to protect. One is the chat, the open chat that's visible. And then now we have a countdown application. I'm just going to take a quick break and show you something else that's interesting. This is using the Cyberbot robot. Cyberbot. So when you plug the microbits into Cyberbot robots, you can do some kind of interesting things. And these are also things that students will want to protect. So in this example, let me back up a little bit here. In this example, we have the instructor computer, and it has a microbit connected to it. And the script that is being run here is essentially this microbit's running a script to take wheel speeds and run times from this terminal, this serial monitor, and send that, put that into a dictionary and send it out. And then all the microbits all the microbits on Cyberbot robots in the classroom are receiving this data, and then we'll take action on it. And that's an example of robotic or mechatronic data that can also be sniffed and interfered with. And that's one of many examples. Another one that's kind of fun is the tilt control. And so that is right here. And basically, one microbit is being tilted, and it's radio transmitting that tilt data to the cyberbot, and the cyberbot is figuring out what that tilt data is about, and it's setting its wheel speeds and directions accordingly. So those are additional kinds of things that you can add to the list of things that students will want to protect in, for example, a robotics contest, if you have a fleet of Cyberbot robots as opposed to just a collection of microbits. But clearly there's quite a lot to be done with just the microbit. So that's why we peeled the microbit only parts off into the cybersecurity lessons. All right. So here's our distributed countdown. So now we have, but I meant to talk about the data a little bit. Okay, so here we have the countdown start, which is coming through as text. I mentioned earlier that to turn text into an integer value, you use the int function. So if I typed the number 3, that's the character 3 really. And so int of the character 3, or a string with one character that happens to be 3 into it, gets changed into the number 3 and stored in value. Then the next message is actually saying the message equals whatever comes in response to the input of enter message after countdown. Since input always gives a string, we don't need to change it. Message can just hold that string. Then an empty dictionary is created. A start field or a start value is added, and it gets the variable value. And then after gets set to whatever message is. So in the end, what we have is something that's going to, actually, we can see those dictionaries, the result. I'll just rerun this here and point out what the result looks like. So 2, kaboom. All right, so here we see what that did. It took, it added the start right here, and that's the key, and then the associated value in the key value pair is 2, and then after was the message kaboom. And then that got all stuffed into a string right here, str of the dictionary. I used the unimaginative name of dictionary for our dictionary, which is this thing that's contained between the 2 curly braces. Then after converting it to a string, that string is named packet, and then radio.send of packet sends it out. On this end, it's waiting to, it's repeatedly checking radio receive, and then it's assigning the result to packet. Well, if there's nothing coming in, it puts none in packet. But eventually it'll put a value, and then if packet is not none, we'll go through and it'll change that string back to a dictionary, and then it'll go and ask the dictionary what the value associated with start is and what the message associated with after is, and then it will continue to do its little countdown. And again, that's examples of stuff to protect, and now we are into how to protect that. And so we're starting with nice basic stuff, which we alluded to earlier with that little pop quiz I gave you. We're going to use the shift or a shift cipher, namely the Caesar cipher, for starters. And we show how if you have a key like the number 5, you can say, oh, well, I'm starting with H as my plain text. And so I want to count over by 5. And when I do that, I get to M. So M is my secret ciphertext. And then likewise, the E in hello, well, we count over 5 and that becomes a J. And then when it's all done, HELLO becomes MJQQT. And then for decryption, it simply has to go the opposite direction. And there is a special case when decryption or encryption goes past the end of the alphabet or to the beginning of the alphabet. So if you're trying to send an X, that character might actually be a C if your key is 5. And yeah, so this going with the classical Caesar cipher seemed like a good way to put together some of the material that with using strings, especially it's a little bit more tangible than using some kind of bitwise encryption. This is, I think, a better starting point. So encrypting a single letter is pretty easy. If you start with a key of 5 and the letter M, here's an alphabet string. And then, shoot, I skipped over it. There was a string.find. And what that does is it returns the index of a letter. And so basically, alpha is the alphabet, and then alpha.find of the letter M basically goes and finds the letter M and says what its index is in the string. And then to do the encryption, basically you can say, well, that the index of M is whatever number that is. Let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So its index should be 12, and then we'll add 5 to that to get 17. And just in case we have that wraparound situation where like X had to be encrypted as C, this little % sign, which I skipped over earlier, it's talked about in the scripting basics as an operator that essentially gives you the remainder of a division problem. So if we added 5 to X, which might be XYZ, its index might be, I think it's going to be 24 or 23. Then when we add 5 to that, we're over 26, but we want to wrap around to C. And so this says, well, if you divide 26 into say 28 or 29, or let's say 29, what's the remainder? And the result is going to be 3, and then that get, or probably 2. I'm, you know, getting my numbers off, but hopefully the idea is that if you divide by 26 and take the remainder, that will give you the expected C if you typed in X. And so we should try that. We should replace M with X to see that in action. So here is your script, paste, and go ahead and I'll just give you the web address for the page too. Yeah, so it's 12 and then 17. So if we try that in our okay, so here we have the letter M, which has an index of 12, and then when 5 is added to it, the result is R. So that's our encrypted, C's are encrypted value. Now, if I change the letter M to the letter X and send it to microbit, and capital X, by the way, I don't think we have any case insensitive code yet. So now the result is 2, which is the index of C, ABC 0, 1, 2. And so that is why the modulus operator that takes the remainder of dividing 26 in and gives us what's left over is a great way to wrap around, as we saw in here we are. As we saw here, where we have X and it goes over and wraps around to C. Here is a terminal example of that, where we can start typing characters into the terminal and have it give us the results. Paste. Enter key 5, enter a letter, capital H, capital E. Well, that was weird. Capital H. Oh, the key, enter, you have to enter the key each time. I forgot about that, sorry. So basically we're entering a key of 5 and then the H from hello. Remember, hello was MJQQT when the key was 5. And then we have to enter a key again, 5, and then capital E, and then we get the J from MJQQT for hello. And then this ASCII cipher is one that we use a lot in the upcoming examples. And so I'll go ahead and paste this one to you. enter key 5. Enter printable characters, hello. And it gives us MJQQT. Now, to decrypt, we want to enter a key of -5. And then we could type in that MJQQT and get back to hello. And give me a thumbs up when you were able to make that one work. Christine? Kevin? Everybody okay? Okay, very good. All right, now we've got some thumbs up coming through. Oh, very good. And I feel like, let's see, that's an entire word encrypted and decrypted. But I feel like I'm missing the part where this is just some kind of interesting other ciphers. Um, yeah, okay, so that's where the cipher intro stops, and then we move on to sniffing attacks and defenses. And so let's start with sharing something personal. And to mix things up, we're going to do this with the microbit. And what we'll do, since we only have 2 microbits, is we'll first have our transmitter and our intended receiver, and then basically send happy, sad, and angry as emoji across from the transmitter to the receiver. Now, then we can also say, well, gee, if I had a 3rd microbit and there was no encryption, that 3rd microbit, which will be your 2nd microbit, the receiver, could also be a sniffing microbit. Okay, and so what I'm going to have you do is get this going, the unencrypted version. Basically, you'll be taking the transmitter script and copying it into one editor, and then the receiver script and copying it into the other editor so that they both show so that they both essentially show the same emoji. So here is the web address for that. And in the classroom, the students can be split up into groups of at least 3 so that there's a transmitter, an intended receiver, and a sniffing attacker. And for this one, you won't see anything in the terminal. This is going to be in the on the microbit. And for some reason, I'm only showing the oh, I'm sorry. Okay, so so we have the transmitting microbit here showing angry, then happy, then sad. And then our receiver microbit right now is displaying those received messages in the terminal. And so the idea is that right now, either the transmitter, either the intended receiver or the sniffer has access to this information because it's not encrypted. And then this shows how to make the I believe that this shows how to display the image on the receiver microbit. Yeah, no, it should be displaying. I wonder if I missed the last line. No, it's yeah, I'm not really sure why I'm not seeing a display here. I'll have to take a look at that and get back to you on probably Friday. Because I intended to be able to see the equivalent image here, but it's not showing for some reason. At any rate,
We
okay,
do have
so
a report from a couple of people that it's working for them.
really,
Mm-hmm.
oh, interesting.
In your chat.
Okay, sorry, I missed it. So you can see the image on both the receiver and the transmitter. Yeah, well, that's the way it's supposed to be. I wonder what on earth is happening for my microbit. Well, I don't know. I'm not gonna
Not
dwell
for
on that right
everyone,
now.
though. Okay. Not on the receiver, only on my receiver.
Yeah, I wonder if something changed with the version 3 editor and the way it puts that together. That sounds like something that I might want to be sending to the
I did get an email forwarded to me of a report that someone was saying a particular activity was no longer working on the version 3 editor. And
Okay.
that went to education just today. So you may not have seen that yet. I haven't looked into it yet, but it is possible.
Okay. Yeah, I missed that.
It's new breaking news. So
Okay. So not seeing any code in the transmitter that would display it. Basically, oh, yeah, I think that, who was that?
Raimundo may be onto something.
Yeah, I think so. Yeah, it looks like I had the two microbits confused. Basically, the receiver, this guy's the receiver here. This one is the one that is displaying the different emojis. So this is sending but not displaying. So to make this one also display, we'd have to go in and essentially add display.show of packet probably. Wonder if that works. Might be it might give me a bug. Oh, you know what? Because it's inside of a string, I'd actually have to say happy or do some code to convert happy to image.happy.
You have about 20 minutes, so
Yeah,
maybe.
okay, you're right. Thanks. Okay, let's forget about that for now. And move on to encrypting that data. Okay, so what's going to happen here is that we're going to see what's going to happen for the sniffer first, because what we'll do is we'll update our transmitting code first, and then we'll update to the intended receiver's code. So basically, what we want to do, let me see if I can paste this in. So this should go to the transmitting microbit. So we want to update the transmitting microbit to have this script, and it will actually cause an exception in the receiver microbit. So when I start sending the encrypted version here, it immediately crashes the microbit that was, sniffing for unencrypted data. And would anybody like to comment on how a hacker would respond to that in order to keep sniffing and prevent prevent their microbit from crashing?
Unplug.
I'm sorry?
Unplug.
Well, yes, we could unplug it. Don't do that, actually. Basically, they would modify their script to use exception handling, and then that way they could see, because basically what's happening is in the receiver script that's trying to do sniffing, it got KDSSB. That's probably HAPPY, and it was unable to take that and put it back together into display.show, because KDSSB is not HAPPY, which is a real thing for display.show, whereas KDSSB is not. And so that's why their script crashed, but they could use the exception handling that we talked about on Monday to prevent this from stopping the microbit in its tracks by checking to see if it causes an exception, displaying the exception, and that kind of stuff. And that there's actually a tutorial page coming up on that, but I want to skip that because of time constraints. So I'm just letting you know it's there, that students are guided through what an cyber attacker would do as well. So now let's go ahead and update our receiver script with, did I chat that? Did everybody get that yet? Send, there we go. Okay, so now if we update the receiver script and run it, then we should be back to decrypting, and it's showing the encrypted and the decrypted version in the terminal, in both terminals actually, the transmitter and the receiver. And then now we also have both transmitter and receiver displaying identical icons. And I'll be right back. I'm going to turn off the lights above me so that we can see the microbits a little bit better.
Andy, you are muted.
Andy, I only see one account from you. The other is gone.
Okay, how about now? Can you hear me?
Yes.
Okay, very good. My apologies. So we're going to look at encrypted versus unencrypted data. And so I chatted everybody the encrypted chat transmitter. And we'll have you load that into 1 microbit. And then I have to run and find the other radio basics. Okay, so this will we'll put this on the other microbit just to see what the so this is the one we ran earlier. So we're sending and receiving encrypted data from 1 microbit, and then we have a sniffing microbit that is looking for unencrypted data. And so basically we'll run the encrypted microbit and the unencrypted sniffer. We'll enter a key. And just to keep things simple, I'm going to stick with 5. And then I'll type hello. And notice that the sniffing microbit sees MJQQT. And so this is an example of making it so that the the chat is no longer open. There's some modicum of protection through the next step up from Caesar cipher, which is just basically accepting any ASCII character, regardless of whether it's capital or lowercase, and shifting it over in the alphabet. Now, if we take the second microbit, and instead of having it be a sniffing microbit, we'll go ahead and put in the equivalent, basically the same script in the second microbit. Key of 5. And the key is already 5 over here, so I should be able to say hello. And yes, it receives hello. Okay, so what I did on the receiver is I modified it to show both the encrypted and the unencrypted. You can try that on one or both of the, or on the receiver. I didn't modify the transmitting one. But this is also something that's done in the lesson. So you can see that if I type hello here, we get both the encrypted version and the plain text version, the ciphertext version and the plain text version. And we also do the same thing by encrypting the countdown data. And I'm going to go ahead and skip that since we just have a few minutes left. We'll get started on brute force and then finish that off at the beginning of Friday. So brute force attacks. We start students out with an introduction of a bike lock that has 4 digits. And so that could give you, if the digits went clear up to 10, which they don't in this case, but if they did, then you could go from 0 to 999 or 9999. So so basically there's 10,000 combinations that you'd have to go through. And so the more digits, the more combinations, and the more difficult it is to break into or to basically to brute force any kind of lock. And so we start with a microbit pin pad, and the main idea that we're trying to convey here is that the more digits, the more digit options and the more digits you have will affect how difficult it is to crack crack the code. And so so it turns out that in the example we'll try next, the correct code is 011, and we'll see a check mark meaning access is granted, or 101, or any other number, access will be denied. So here is the transmitter. And here is the receiver. Paste. And when you run both of these, don't remember exactly what you see. I don't think you see much of anything on the serial monitor, but if you look at your microbit, you'll see that one has a little dot in the lower left, and the other has a dot in the center. So this is our safe, and this is our digital pin pad. And to toggle between 0 and 1, you just hit the A button. And so and then to go to the next digit, you hit the B button. And so if I type in 101, I get an X because that was not the right code. The right code was 011. So here's 0. So I can hit the B button to go to the next one, then hit the A button to make it 1. And then I have 011. And when I hit B one more time, we get the check mark for access granted. Now, cracking that with brute force involves trying every single possible combination. And there aren't very many. There's only 8 because we have 3 zeros and 1s. So that's 2 times 2 times 2 in terms of options. But this will, oh, this is too long. Okay, I'll have to give you the web address for this one and have you copy it into, now you'll copy this into your pin pad microbit. So the microbit you were using as a pin pad is now the one that you want to use as an attacker microbit that's going to brute force. So the pin pad transmitter is the one you want to overwrite.
We have a question. Can we have more than one trying to get the code at the same time?
I think there might be some collisions. We normally have students pair off with this one. Yeah, I think it could probably be modified to take requests and deny them more quickly. Right now, there's all these sleep statements in these guys, and there's actually a lesson just a few pages away that talks about how if you have 3 incorrect tries, then the safe sleeps for an hour before you can try again, as an example, to increase the level of security on an access code. Okay, so now your pin pad, so your safe is still just waiting for input, but your pin pad is going to have a little arrow on it. And when you press the button that the arrow is pointing at, it starts going through the different combinations. So 000, 001, 010, and then on 011, look at that. It found the access code. And so that's a little microcosm of how brute force attacks work. And the next thing we do is go with decimal numbers and see that it takes a lot longer for the brute force attack to actually open up the microbit vault over here. And with that, we are just about out of time. So I would like to, we'll go ahead and resume some brute force examples on Friday. And I just want to let you know that those of you who are not already part of signed up at learn.parallax.com will end up getting an email letting you know that you've been set up with an account at learn.parallax.com. And that's because you're all teachers, so we can do that. And then sign in, follow the instructions to sign in to learn.parallax.com, and it won't actually interfere with anything anything that we're doing hands-on participation of on Friday, but it will be nice just to be able to get into the assessment materials on learn.parallax.com. So basically the homework you're going to get is going to say, if you're already part of learn.parallax.com, that means you didn't receive an email like this one. So that means that you'll want to just try to sign in using your credentials that you've created in the past. So if you're already in learn.parallax.com, just go and try to sign in. If you have not signed up with learn.parallax.com, we'll sign you up and send you an email letting you know what to do. And I just want you to try it out and get signed in. But also, if you are, for whatever reason, unable to sign in to learn.parallax.com by Friday because of, I don't know, the email didn't make it to your inbox or whatever the cause is, don't worry, it won't interfere with Friday's activities that are hands-on. It'll just be show and tell, but you'll know that you can repeat the show and tell that I did and get to the assessment materials. So that's your homework. I might add in just, something like one little thing to read and try on your microbit. I haven't decided what that might be yet. And then we'll look forward to seeing you on Friday. Make sure again to have both your microbits connected and set up so that they're identifying themselves as A and B. And then we'll take it from there and we'll resume brute force. And then I'll show you a little bit about malformed packets. And then we'll talk about some other resources that you can use. Maybe take a closer look at the the AI examples, and then the teacher resources, where you can purchase microbits, and some final questions and answers, some robotics examples, and then we'll go ahead and wrap it up for the week. All right, so thanks for coming, everybody, and we'll look forward to seeing you again on Friday. Please feel free to stick around if you have any tech support issues that you need help with on the microbit, or any comments or questions. We can take those after the recorded portion. And aside from that, we'll look forward to seeing you all on Friday. Thanks for coming.
Thank you. Bye.
Take care now.